There are so many different types of motion that occur in our universe. Motion occurs when the distance between the object and a reference point is changed, with the reference point being a point or place that's used to determine if an object is in motion. Motion can be described by two major quantities, vector and scalar. Although neither vector nor scalar is the topic of this video, it is extremely crucial to know what they are, and therefore I'll be talking about it very briefly. It is fairly simple. Scalar quantities are ones with only magnitude, such as 20 kilometers per hour, and vector quantities are ones with magnitude and direction, such as 20 kilometers per hour, north, east, up, down, or etc. First, I'll be talking about one very useful scalar quantity, speed. Speed, as you guys might be the most familiar with, is basically the rate of motion or the rate of change in position. Speed is how much distance an object travels in a period of time, or simply distance divided by time, which will make the units meters per second. Let's use this concept in an actual problem. Obviously, when you look at his starting point and 10 meters, the distance is 10 meters. Since the fullback ran 10 meters in a second, if you put it in the formula distance over time, his speed for the first 10 meters was 10 meters per second. If you do the same for all the other splits every 10 meters, you can see that the fullback is moving 10 meters every second. This means he has a constant speed and thus covers the same distance, 10 meters, in each consecutive second. He is certainly not accelerating. Now let's move on to velocity. Although velocity is very similar to speed, it is a vector quantity, which means that it includes both magnitude and direction. As you guys might notice, Usain Bolt is changing directions during the 200-meter race. Thus, velocity is a rate of motion in a specific direction. In speed and velocity, there are two types, instantaneous and average. Instantaneous speed or velocity is at a split second in time, whereas average speed or velocity is in a certain period of time and seeing how fast it moved during that period of time. Going back to the question about the fullback, this question talks about instantaneous speed because it gave us the speed of the fullback every 10 meters. Velocity is basically displacement divided by time. All you need to do is divide displacement, which is the distance you've traveled from your initial point, by the time elapsed. This is a table for the lab that we did in class called Pipettes Away. It was an experiment where we calculated the velocity and radius of the blobs of water, which we dropped using pipettes at different heights. As you can see, since the displacement was 0.5 meters, we divided 0.5 meters by the average time, which was 0.93 seconds to get a velocity of 0.54 meters per second. We used the same method to calculate the velocity for all the other remaining heights. Finally, I'll talk about acceleration. Acceleration is a rate of change of velocity over time, and the formula is final velocity minus initial velocity divided by time. This is also a vector quantity, and whenever velocity or direction changes, there's always acceleration or deceleration happening. Also, the units of acceleration is meters per second squared. This is my dog doing 5-meter sprints filmed in two different angles. This is a table that we made for the time it took him to run each meter. I then went ahead and calculated the acceleration. Since acceleration is final velocity minus initial velocity over time, when you look at the acceleration between 0 to 1 meters and 1 to 2 meters, you have to do 1.43 meters per second minus 1.25 meters per second divided by 1.5 seconds, which is the sum of 0.8 seconds and 0.7 seconds, which leads to an acceleration of 0.12 meters per second squared. If you use this formula for the other distances, my dog had a positive acceleration between 1 to 2 meters and 2 to 3 meters, and the acceleration between 2 to 3 meters and 3 to 4 meters was 0, which means that he had constant acceleration. Lastly, in the final frame between 3 to 4 meters and 4 to 5 meters, his acceleration was negative, which meant that he decelerated.